Yo, AP Calc, let's kick it. Ice, baby. Ice, baby. Alright, stop. Do subtraction and addition. Calc is back with a brand new equation. Calculators are very pricey. Doing my homework daily and nightly.
Will it ever stop, yo? I don't know. Trig makes me want to crawl in a hole. To the extreme, we find limits wearing sandals. Fill up the board with math problems like a vandal. Dance. Listen to the teacher that boom. Calculus your brain like a poisonous mushroom.
Deadly. When I find out velocity. Integrals are a human curiosity. Love it, leave it in class every day. You better find the maximum because Toby don't play. If you got a problem, yo, I'll solve it. Check out the book. Well, students love me tall. Ice, baby.
Calculus.
Ice, baby.
Calculus.
Ice, baby.
Calculus.
Ice, baby.
Calculus.
Mommy, come look at my duck. Looky.
That's a beautiful duck you have, dear.
But now I can't reach it.
How should we get it back?
Oh.
Maybe we could use this string.
Oh, yeah.
Maybe we could use this string and tie it around his neck. It's okay, honey. He's just a duck. And attach it to the faucet to pull him in.
Okay. Hey, Mommy.
Did you know that a bathtub is just a word for spout?
She's a genius. Let's do some math.
Okay.
If the faucet is 1 meter high and we pull this string at 1 meter per second, how fast do you think the duck's moving when he's 8 meters away?
I don't know. I'm only 5.
Let's call a mathematician. We need a mathematician. Dad.
Did someone call for a mathematician?
It's about time you showed up.
Oh, booey. This is like a really hard problem. I'll help you out with it. Don't worry.
Okay.
So basically, in that bathtub, we have a right triangle. So you have the horizontal distance from the rubber duck, which is over here, to below the faucet, which is over here. We'll call it X. And you have the vertical distance from the faucet to the water level, and we'll call this Y. And then you have the distance of the string, which we'll call Z. In general, we know that the equation, by the Pythagorean theorem, we know that x squared plus y squared is equal to z squared. So, problem, we know that the x distance is 8 meters. So I'll just put it down here.
That's a horrible distance.
Correct. High five. We know that this distance from the water line to the faucet is 1 meter.
That's the vertical distance.
And we don't know this distance, but we can use this equation to find it. So
That's the vertical distance.
So 8 squared is 64 plus 1 squared is 1, so that's 65 equals z squared. So then you can just take the square root of both sides. So that'd be z equals
Let's go underground.
the square root of 65. So now we also knew that the change in distance of the string over the change in time, which you can call dz over dt, is equal to -1 meters per second. We know that this distance isn't changing because the water level isn't getting closer or farther away from the faucet. So I can call dy over dt is 0. What we're trying to find is the change in distance over the change in time for the horizontal line.
Okay.
So we're looking for dx over dt. So to find this, we can take the derivative of the equation and then plug in all these and find dx over dt. So we're going to take the derivative of this equation with respect to t. So, nail down here. So we got the power rule. We got 2x times dx over dt plus power rule 2y times dy over dt is equal to 2 c over. I swear my handwriting is better than this. And then all these 2's can cancel out. So we're left with x times dx over dt plus y times dy over dt equals d times dz over dt. Okay, so we know that x is equal to 8 meters. We're looking for dx over dt, that's what we're trying to find. Y is equal to 1 meter, and then dy over dt is 0, and that equals z, which is root 65, times dz over dt, which is 1. So now 1 times 0 is just 0, so that cancels out. And then we can divide both sides by 8 to get dx over dt by itself. That's negative 1. I keep that, it's negative 1. Yeah. And then, so dx over dt is equal to negative root 65 over 8. Which, if you calculate it out, it becomes 1.01 meters per second. And the negative doesn't matter because it's moving in a positive direction.
Oh, because you can't have negative velocity.
Right, you cannot have a negative velocity.
Okay. Thanks, mathematician. Mommy, come look at my boat.
You got water in the top of the boat, honey! There goes our boat! It leaked through! No! You should have bought a toy boat. Yeah, count me down. Count me down. 3, 2, 1, go.
Day. Bet on the next one so we don't play. If you have a problem, yo, I'll solve it. Check out the hook. Well, since I said
We were so good!
we've got it down.